You ever see one of those massive natural stone bridges and just think, how? How is that even possible? Well, today we're talking about the ones that weren't built by anyone. They were carved, impossibly, by the slow, steady power of a river. So how does plain old water cut right through solid rock? Let's dive in.
I mean, you look at them and they just seem deliberate, don't they? They're these soaring arches that look so perfect, so architectural. It's hard to believe they're just accidents of nature. You'd swear you were looking at the ruins of some ancient empire, but the architect here, it was just water.
And that's the big mystery, right? If nobody built them, how in the world does a river manage to carve a tunnel straight through a mountain of stone? Well, the answer is an incredible story that involves brute force, a little bit of chemistry, and a whole lot of time.
Okay, so let's start to piece this amazing geological puzzle together. These incredible, impossible-looking arches. They aren't just objects. They're the grand finale of a process that is almost unimaginably long and slow.
And what's so cool is that this isn't random. It's actually more like a recipe, a very specific recipe. You need 4 key ingredients to get started. First, you need flowing water, obviously. Then you need the right kind of rock, something erodible like sandstone or limestone. You also need some weaknesses in that rock, fractures or joints for the water to attack. And of course, the most important ingredient of all, an immense, almost unbelievable amount of time.
So, if those are the ingredients, what about the tools? I mean, a river doesn't exactly show up with a set of hammers and chisels, but in a way, it actually has something much, much more powerful.
Turns out, a river has a 2-pronged attack. First, you've got what's called mechanical abrasion. Just think of it like nature's sandpaper. Every single grain of sand, every pebble the river carries, scours and scrapes away at the bedrock, day in and day out. But at the exact same time, there's a sneakier process happening: chemical weathering. You see, rainwater is naturally a little acidic, and over thousands and thousands of years, it literally dissolves the glue, the minerals holding the rock together. It weakens it from the inside out.
This all comes down to one absolutely crucial concept: differential erosion. It sounds technical, but it's simple. The river is smart, or maybe just lazy. It doesn't waste its energy trying to carve through the hardest, strongest rock. No way. It seeks out and attacks the softest, most fractured parts first. This is the real secret. It's how the river can sculpt such a precise, elegant shape instead of just washing everything away.
Okay, so the river has its tools and it's found its target, the weak spot in the rock. So how does it actually pull off this incredible feat of engineering? Well, let's watch how it works. So the first method is kind of like a relentless siege. Picture a river making a sharp turn, and all its force is focused right on the side of a rock wall. For centuries, it just grinds away, carving out a little cave or an alcove at the base. That recess just gets deeper and deeper and deeper until, one day, boom, it punches all the way through to the other side. That very first moment that daylight shines through, that's it. A brand new arch has just been born.
Now, the second method is, I think, even more clever. It's like a brilliant, natural shortcut. You know how rivers get really loopy, making those big S shapes? Well, sometimes a loop gets so tight that the land between the two bends, the neck, gets super narrow. The river starts eroding this neck from both sides at once, and eventually it just says, forget this long way around, and cuts a tunnel straight through. The river takes its new, shorter path, and what does it leave behind? A perfect, freestanding stone bridge.
Now, we've been talking about processes that are just impossibly slow, unfolding over geological time. But every once in a while, nature gets impatient and decides to hit the fast-forward button.
And that accelerator is a flood. A single, massive flood event can multiply a river's carving power by 100 times, or even more. Think about that. In just a few days, a flood can do the work that would normally take thousands of years, carrying huge boulders and scouring out rock at an incredible rate.
And of course, the local climate plays a huge part in how these bridges form. In really humid, wet regions, the work is slow but constant, 24/7. In cold places, you get this amazing freeze-thaw cycle where water gets into cracks, freezes, expands, and basically wedges the rock apart. And then you have deserts. Deserts might seem dry, but their rare flash floods are so powerful and carry so much sediment they act like liquid sandpaper, carving things out with shocking speed.
So once an arch finally forms, you might think this story is over, but it's not. Not at all. Its creation is really just the first chapter in a much, much longer story. You know, an arch really has a full life cycle. Its birth, the formation, might take thousands of years. Then, for potentially millions of years, it grows and evolves as the river keeps widening the opening. Sometimes the river moves on entirely, leaving the old bridge high and dry. But, nothing lasts forever. Weakened by gravity and the elements, every single one of these stone bridges is destined, one day, to collapse back into the earth.
And that's exactly why there's so much more than just beautiful things to look at. They're geological storytellers. They're time capsules. Each one holds the record of ancient rivers that are long gone, of forgotten floods, of climates that have completely vanished. They literally preserve a chapter of Earth's history in stone.
Yeah, this quote just nails it. Their beauty is temporary, and that's exactly what makes them so special. They are a snapshot, a fleeting moment in the constant, powerful, dynamic reshaping of our world.
It really makes you wonder, doesn't it? As we stand here admiring these ancient arches, what's happening right now deep in the bedrock beneath our feet? What incredible new structures are being carved out millimeter by millimeter, just waiting for their turn to finally see the daylight?